All right, let's do some hyperbola equations. So a hyperbola is a conic, and of course they can either be horizontal or vertical, just like the ellipses. And the horizontal hyperbola equation looks like this, right? Where a squared is under the x squared term. So this is a horizontal hyperbola. The vertical hyperbolas have a squared under the y squared term. All right, and remember that with ellipses, the way you know a from b is a is always the bigger number. Well, in hyperbolas, a doesn't have to be the bigger number, but a is always under the positive term. All right, so let's look at the hyperbola equation. Let's explain it using an example. So here's my example equation, x minus 5 squared over 16 minus y plus 2 squared over 4 equals 1. So just as in the ellipses, we want to find a, b, and c because they're going to help us understand this hyperbola. All right, well, first I'm going to start with hk, the center. hk is the center just as it is in the circle and in the ellipses. And hk for this one is 5, negative 2. So when I start to graph my hyperbola, okay, then I want to come over 5, 1, 2, 3, 4, 5, down negative 2. This is the center of my hyperbola. All right, now a, remember a squared is always under the positive term. This time a squared is 16, so a is 4. And since the x squared term is positive, this is a sideways hyperbola. So I'm going to go 4 units to the left and 4 units to the right to get my vertices. All right. Well, this is 4 units to the right, puts me at 9, negative 2. So one of my vertices is at 9, negative 2. And the other vertice, the other vertex, 1, 2, 3, 4, is going to be 4 units away from the center to the left. And it's going to be at 1, negative 2. Okay. So those are my vertices. So this is going to be sideways. Now, b is going to help me get the curve. So b squared is under the negative term. So b squared is 4, so b is 2. So I'm going to go up 2 from the center and down 2 from the center. And what I'm going to do is I'm going to draw horizontal lines through my b's. Okay, of course, this one is the x-axis. That line's already drawn. And I'm going to draw vertical lines through my vertices. And then I have this rectangle. Now, I really don't need the extensions here. But what I do need to do is I need to use my rectangle. I'm going to draw the diagonals through my rectangle. All right, so here's my diagonal. And here's this diagonal of my rectangle, and they're my boundaries for my curve. So you see this side of my hyperbola hugs that asymptote, comes through the vertex, see? And on this side, we hug the asymptote, come through the vertex, and up this way. So it's like 2 sideways parabolas. Now, just as in the ellipses, C helps us find our focus. Okay, and we've got 2. We've got 2 foci, one right here and one right here. All right, well, let's find C. Now, the equation for C with the hyperbolas is c squared equals a squared plus b squared. It's exactly like the Pythagorean theorem. Remember that for an ellipse, c squared was equal to a squared minus b squared. All right, well, c squared is equal to, and then a squared is 16, b squared is 4, and 16 plus 4 is 20. So c is equal to the square root of 20, which is 2 square root of 5. All right, well, that's going to help me find my focus. Now, the square root of 20 is about halfway between the square root of 16 and the square root of 25. So it's about halfway between 4 and 5. So we'll estimate it to be around 4.5. So I'm going to go 4.5 units from the center horizontally to find my foci. That's 1, 2, 3, 4.5. Gives me a focus there. And 1, 2, 3, 4.5 gives me a focus here. All right, so those points are, here's my center at 5, but it's going to be 5 minus 2 square root of 5, negative 2, and then 5 plus 2 square root of 5, negative 2. These are my foci. The last thing I want to identify with this hyperbola are the asymptote equations. Now notice that all of these lines except for my curve are dashed. That's because they help me draw my hyperbola, but they are not actually points on the curve. All right, well, let's write the line equations for these asymptotes. Now you'll notice these asymptotes actually have the same slope, but one's positive and one's negative. And we use the point-slope form of a line equation to write their line equation. All right, now the point that these asymptotes go through is always hk, so you could write this equation as x minus h here, y minus k here, because that's the point you're going to put in to your line equation. And the slope is either going to be a over b or b over a. Well, in this case, our slope is change in y over change in x. My change in y was my b, and my change in x, this distance from my center to my vertex, is a, just like it was for ellipses. B doesn't really give me a point on my curve, but it's this change right here. So slope is b over a, change in y over change in x. And one line's positive and one line is negative. All right, so for this equation, I have y plus 2 equals plus or minus, and then 2 over 4 x minus 5. Or, clean this up a little bit, y plus 2 equals plus or minus 1/2 x minus 5. These are my asymptote equations for my curve. Now, let's do one more example. All right, so this time we'll do a vertical example. Okay, remember that your vertical hyperbola has a positive y squared and a negative x squared. All right, so here's my equation, y squared over 4 minus x plus 1 squared over 9 equals 1. Okay, so I want to find a, b, and c. All right, so a, b, c. Remember that a is always under the positive term. It doesn't necessarily have to be the largest number. Well, this time a squared is 4, so a is 2. And b squared is 9, so b is 3. And then hk, h is negative 1, k is 0. There is no number sitting with y, so it's 0. All right, so let's graph this. So my center is negative 1, 0. And a is 2, but this time it's underneath the y, so we're going to go up 2 and down 2 to get my vertices. All right, so here's one vertex, and then down 2, here's the other vertex. All right, so the points negative 1, 2, and negative 1, negative 2 are my vertices. I get those using a. All right, so I can go ahead and draw my horizontal lines through a. Now let's use b to complete my rectangle. B is 3. This time I'm going to go to the left 3. And I'm going to draw a line through that number, and then to the right 3. 1, 2, 3. Draw a line through there. Now I have my rectangle, and I can draw my diagonals. All right, so my diagonals are going to go just like this. And now remember that my vertices were actually above and below the center. The asymptotes are my boundaries, so my curve hugs the asymptote, comes across through the vertex. Same thing on the bottom, hugs the asymptote, comes across through the vertex. And there's my hyperbola. All right, so let's use c. Let's find c so that we can find our foci. C squared equals a squared plus b squared. Well, a squared is 4, b squared is 9. So this is 4 plus 9, which is 13. So c is the square root of 13. All right? Well, the square root of 13 is roughly between 9 and 16, the square root of 9, square root of 16, so 3 and 4. So let's just estimate around 3.5. So I'm going to go 3.5 units up or down from the center to get my foci. So 1, 2, 3, so here's about 3.5. So this is 1F, and then 1, 2, 3, and here's the other, about 3.5, the other foci. So my foci are -1, and then -1 is my x, and then the y is the 0 plus or minus c, which is square root of 13. So it's just plus or minus the square root of 13. These are my foci. All right, and the last thing I have to do is write my asymptote equations. Y minus, remember, our point is hk, so y minus k equals my slope, and then x minus h. Now this time, my slope, the change in y, happens to be a. A is always the distance to the vertex. C is the distance to the foci. All right? So notice how C is always bigger than A with a hyperbola. But A is my vertical distance for my slope of my line. A is my vertical distance, and B this time is my horizontal distance. So my change in y is A, and my change in x is B. So my slope is going to be plus or minus A over B, depending on which line, it's plus or minus. So y minus k, k is 0, equals, and then A over B, 2 over 3, so it's plus or minus 2 over 3, and then x plus 1. And these are my two asymptote equations.